Okay. Yeah, thank you very much. So, why Gradle? Requirements in the automation space have changed tremendously in the last 10 years. So, I remember when N came out, when I was so happy, I could just copy my files, I could build my jar. That was all what I wanted to do at that time. That was before test-driven development, before continuous delivery, before the whole agile movement. And all those new movements have added a lot of requirements, for good reason, onto the automation and the build system, which is kind of at the heart of Gradle to deal with this much more complex requirements. Building your jar and publishing it somewhere is a tiny part when you get serious about automation. The other reality we're now entering is heterogeneity is not a legacy burden, heterogeneity is the future. Scala, Java, JavaScript, Android, iOS, etc., etc. That's another focus of Gradle, to be a premier build system for all of those platforms. Okay, so I just want to show two things that I like with Gradle. So this is not an overview, this is rather a kind of live coding deep dive into some cool features. Okay, incremental build. Who of you is doing always N clean, blah, 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 or Maven clean, blah, blah, blah? I guess the majority. And if not, there's not much you gain from not doing it, right? Okay, so this is a simple Java project. The name of the project is called Incremental. And we just tell Gradle, hey, this is a Java project, so we have all the build by convention, Maven-like feeling and functionality. So I now go to the command line and tell Gradle, hey, build the whole thing. First do a clean and build it. What we see, everything is built. We see a couple of interesting up-to-date statements. That means there are no resources to be processed. So therefore they are up-to-date. Nothing has done. The other stuff was just executed, compiled, jarred, tests compiled, etc. So if we now do a build without a clean, boom, everything is up to date, right? So, and you can imagine in larger builds that can save you a tremendous amount of time. So let's see how reliable that is. Let's change some of the production code. Just remove a field from that class and we trigger a build. And Gradle detects the change. It rebuilds the jar to compile, the tests need to be recompiled and re-executed because the class path has changed, etc. So that didn't save you any time, incremental build, but it was reliable. Reliability is first when it comes to smartness, right? Second comes the time you're going to save. So let's do a different change. Let's just remove this comment. And let's see what happens. Ah, that's interesting. So Gradle detected, the stuff needs to be recompiled, but the bytecode hasn't changed. So the jar is up to date, the test class path is up to date, tests don't need to be re-executed. So that was a nice time saver. So let's do something else. Let's go to the build script and change a property. So don't change any of the input files, just the property for the compiler, the source compatibility level. And you see, even this is detected. And because the bytecode has changed, everything basically needs to be re-executed. So if you change the class path of your JUnit dependency, that is also detected, and it causes changes that the tests are recompiled and re-executed, the rest is up to date. So what about changing the output, right? We just changed the input so far. So let's remove one of the compiled classes and re-execute the build. That is also detected. The output change is detected, stuff is recompiled, but bytecode hasn't changed, so all the rest is up to date. Okay, so what about doing this for custom requirements, right? This is kind of what you get built in from Gradle. What about if you have some custom logic where you also want to use up-to-date checking? So we have here a mountains XML file where, don't bother about the height numbers, and the requirement is, for each mountain node, we want to generate a text file where the name of the text file is the name of the mountain and the content of the text file is the height of the mountain. Okay, that is the requirement. Let's give it a first go. Come on, come on, come on. So we just create a task, generate mountain files with some groovy logic that parses the XML and generate those text files. So you don't need to go into the details, just camel case task execution. You don't need to type generate mountain file, you can just GMF, and if there's no ambiguities, it's executed. So the build was successful. Let's check if the result is okay. So we now have a mountains directory with a K2 text and Mount Everest text. Exactly what we wanted. Okay. So now I re-executed the whole thing, and it's not up to date. So up-to-date checking is a feature, a commercial feature you get from Gradleware. No, it's not. So let's re-execute it. Damn, it's still not up to date. Okay, so what's going on here? So first of all, one thing I don't like here, we make a strong point that build script, that the declarative aspect of the build script should be separate from the imperative stuff. We don't want build scripts like that, where you script arbitrarily within, that easily leads to maintainability issues. So what we're doing here now, we extract this into a custom task. We call it convert mountain XML, and we just say, hey, it has an input file, the mountains XML file, a separator, the column, an output directory, the mountains directory, and some action that needs to be executed if you execute a task of that type. So, and then we change that task. We say, this is of type convert mountain XML. As output directory, it's build dear mountains. As XML file, it's a source mountains XML, and a separator is a column. Okay, let's try. I have not much time, so you have to pay attention. And you see, so far, it's clean, so it can't be up to date, but now everything is up to date. And even though there was not so much time for you to check, let's first check whether the files are okay. Okay, let's change the mountains file. The XML file, you see, it was detected, the text files are regenerated, right? The next time you execute it, it's up to date. If you now change the property of the task, the column, the separator within the text file, this is detected, and if you check, it has been rebuilt. Okay, so how does Gradle that? How does Gradle do that? It's extremely simple. You don't say anything about incremental build. You just say, hey, I have a task, and you declare the input and outputs of the task. You can go home now. You understood the concept. It's extremely simple, and you get a very powerful functionality by doing this, right? One aspect is you get incremental build, right? But you also get error checking. If the input file does not exist, you get a nice error message that tells you exactly what went wrong. So it's nothing you as a build master has to implement. Another thing it does, it creates your surrogate task, automatically clean generate mountain files. So you can just clean the output of a particular task. If you have a long-running build where, let's say, the reporting is screwed, but a lot of the output is screwed of a particular task, but a lot of tasks that come before that are long-running, and you're now debugging that task. You now can just tell Gradle, hey, clean the output of that task and rerun it, and then with the incremental build in place, all the other tasks are up to date, and you get very fast feedback on the tasks you're working on. Okay, so that is incremental build in Gradle. So a good build tool must always expect the unexpected. Can't show you many examples for that. I'll show you one in the next set of slides. So build master's delight. Oh, wow, 7 minutes left. Exciting. So, talking about the Gradle wrapper. In Gradle, you as the build master can do the following. We have here a project, it's called Java Standard, and you can tell Gradle, hey, I want to use the wrapper task. This is a task that is not used by the developers, only by the build master. So what the build master can then do, it can, this time from the IDE, execute the wrapper task. And this is a very special task. You see, it creates stuff in your, not in your build output directory, but in your root directory. It has added files like Gradle W and Gradle W BAT and a wrapper directory with a Gradle wrapper jar and Gradle wrapper properties. So the Gradle wrapper jar is only a few kilobytes. So those files that are generated by the wrapper task, you check into version control, right? And the next time a developer does an update from version control, the developer doesn't need to have Gradle installed. It just uses the Gradle W command like the Gradle command, and the wrapper functionality will automatically retrieve the Gradle version you have specified in the distribution URL here, and the build works. And the next time you do an update to a new Gradle version, you just change the Gradle wrapper properties file, check it in, commit it, and for all the developers, they will use the right version of Gradle. That way, you have zero administration on the client side. You have You have nailed down your build, an important part of your build environment in version control. So if you go back to version control a year, which is to a state that is a year old, in version control, it says the exact version of Gradle you need to use to build your software. So it's reproducibility, right? And it's also support calls. Hey, my build doesn't work with that version of Gradle. And you can say, yeah, interesting, but use the wrapper. That is the canonical version to be used, right? And so this is a feature most Gradle users really love. Okay. Another interesting thing are init scripts. So what you often have when you have a larger software stack and you want to standardize certain things in the builds of all the teams, of all the modules, you don't want that the developers need to read a wiki page how they need to set up their build, right? For example, you could write a wiki page. If you set up a Gradle build, specify the repositories, where to retrieve the dependencies to Maven Central, or more likely to some internal in-house repository. So. But this should happen kind of automatically. You want to inject that behavior. So I take this away from that particular build, which is called testing with Gradle, right? And now I create a simple init script where I specify that. Hey, all repositories should be Maven Central. So what I can do now is I can now go to the command line, for example, and can say, hey, run this testing with Gradle build, and inject certain behavior from that particular init script. And voila, you see the build is working, right? It knows now where to retrieve the dependencies from Maven Central. So you can do a lot of awesome stuff in this init script. Gradle provides you a really deep API. Why not add a requirement that says, for example, if any of the unit tests that are run by any build where this init script is injected takes longer than 20 milliseconds, issue a warning. That's where stuff gets interesting. So you ask the Gradle object, which represents the Gradle build runtime of a particular build. After all the projects are evaluated, please hook in the following rule. Give me the root projects, and for all the root projects and its sub-projects, define the rule that for all tasks with type test, hook in a listener, right? Because the Gradle JVM that runs the test provides listeners, that gets notified in real time after a test is executed, and gets some information about the test execution, for example, the time and the name of the test class that was executed. If the time is larger than 20, issue a warning. That's pretty, I mean, in a few lines of code. So, okay, let's do that. Let's re-execute the whole thing. And you see now, in real time, you get the events, and you see we can issue the warning. And it's pretty cool that you can inject behavior. You could, for example, have specific init scripts just on a CI server that enforce certain things on CI. You could, for example, say, locally, every developer can use whatever repository the developer wants to use. But on CI, if you could hook into the Gradle build and ask the Gradle build, hey, what repositories are used? If it's not the company repository, let the build fail, right? But this is CI-specific behavior. So let's now say you want that what is specified in the init scripts is automatically applied to a build. So you want that it's not necessary that an init script needs to be specifically injected. So I can go to my local Gradle distribution that is used for running the builds, and every Gradle distribution has an init.d directory where I can put in one or multiple init scripts. That's what I'm doing here. I just copy what I had in the other init script, and if I now execute this build, this is automatically applied. And now things getting really interesting, because if we go back, because usually you don't want that people mess around with the local Gradle distribution. I mean, they can. But things getting really interesting when we're going back to the wrapper, because you can now specify in the wrapper properties, which we see here, you can now specify your company Gradle distribution, which has in its init.d directory init scripts that define the setup. You can define everything in there, and every person that is using the wrapper will get that Gradle distribution with the init scripts of your company, where you can define repositories, where you can enforce rules, etc., etc. So you have auto-provisioning for your customized build environment, version control, no build wikis that tell the developers how things working. And you can go crazy. I mean, you can go crazy with Gradle in terms of what you want to enforce or what you want to provide. So the Academy of the French language could say, if a task name is not in French, send an email to fire that developer, right? I mean, so Gradle offers you a lot of freedom, but it's freedom for the build master. If you want to use that freedom to be a kind of totalitarian build master, you can do that, right? It depends on your domain. So that is another thing we put a lot of attention to in enterprise scenarios, that to lock down the build environment. And another thing, the last slide on that is you can specify in the project directory a Gradle.properties file where you can specify the Java home that needs to be used for the JVM that is running the builds, and the JVM arcs that need to be used for running a build. So again, no build wiki that is saying set your end ops or Maven ops to that. It is version controlled and it just works and it's per project. We want to enhance that with the Java home, that you can just say JDK 5, JDK 6, and depending on the platform you're using, Mac or Linux, we will figure out the right version. So, oops, that should have, sorry. So, last slide. You can see the full presentation on YouTube. I presented that at the San Francisco Java user group. They did a very nice recording of that. And yeah, thanks a lot for your attention. So. Was it way too fast?